There are many different centers when it comes to triangles, and what we're going to look at today are mainly the point where the medians of a triangle meet, and we're also going to talk briefly about the altitudes. So the medians of a triangle are the points where, if we have a triangle, the median comes from the midpoint of a line segment, and it's going to touch the opposite vertex. So if I'm thinking about this line segment right here, I would find the midpoint, and then I would want to connect that midpoint to the opposite vertex. And that's a median. So midpoint to opposite vertex makes a median. So that's a median. And where all the medians meet, so that would be about right there. And that point where all the medians meet is called the centroid. So the medians form the centroid. And we'll talk about properties of the centroid. The next thing we have is the altitude. So if I have a triangle of any variety, so in a triangle, the altitude of a triangle is perpendicular to a side through the opposite vertex. So if I'm thinking about this side down here on the bottom, I'm going to be perpendicular to it, but through this vertex. So really you're starting at the vertex and coming down so that it looks like it's perpendicular. So for this one, if I need to be perpendicular, I'm going to be about right there. For this one, should be about right there. So this point, these are made up of our altitudes. And the altitudes meet at a point called the orthocenter. So with our current level of knowledge, we don't know enough about the orthocenter to help us with calculations, but we do know things about the centroid. So if we're talking about the centroid, that's this new theorem. So the medians of a triangle intersect at a point that is 2/3 of the distance from the vertex to the midpoint on the opposite side. So here are some steps of how we can figure out where the centroid is to verify the 2/3 rule. So we're mainly going to be dealing with the centroid, and we need to talk about the 2/3 rule in terms of what it really means for our examples. So if we're talking about the 2/3 rule, we're just going to skip that one for now, and we'll come back to it. And if we're verifying the 2/3 rule, we need to know what the 2/3 rule means. And so I'm going to get that picture back just so I can use it. If we have this point in the middle here, let's call it Z. And if Z is the centroid, then our 2/3 rule says that the distance from C, the vertex, to the centroid is 2/3 of the entire distance. So CZ, the length of CZ, is 2/3 of the entire length of CD. And so C has to be a vertex. So we could have used any of our vertices. So AZ is 2/3 of AE. BZ is 2/3 of BF. So all those work. But if we're thinking about it as in like this is 2/3 of the way, then this is going to be 2 times something, and this is going to be 1 times that thing to make up 2 out of 3. So another relationship we have here, if we're using this same point, if it's 2/3, then that means that CZ is also twice as long as DZ. So that's another relationship we can have, or we can say that DZ, the point from the side of the triangle to the circum or to the centroid, is 1/2 of CZ, the top part, from the centroid to the vertex. So all of these come together to form the 2/3 rule, just depending on what we're dealing with. So let's use this to try to make some calculations about a couple different things. So first we have a triangle, and we want to find the coordinate of the centroid and then verify the 2/3 rule. So the centroid is made up of the medians, and the medians connect midpoint to opposite vertex. So if I'm doing this, I want to find the midpoint of a side. So if I'm finding the midpoint of DE, I can think about this slope triangle of sorts, like how much it goes up and over. And I can use that to figure out where my midpoint is. So my up from D to E is 6 units. So half of that is 3. So half of 6 is 3. So if I think about cutting that rise in half, I can find my midpoint. I could have done the same thing with the run. So the run here was 5. So half of 5 is 2.5. I could also think about that line to figure out where that midpoint was. So I just need to figure out where the midpoint is. I can also use the midpoint formula where I add the coordinates together and divide by 2. But once I find the midpoint, just going to get rid of some of this work. Once I find the midpoint of DE, I need to connect that midpoint to the opposite vertex. So it sits on DE, so the opposite vertex is F. So I'm just going to draw a line from there to the opposite vertex. So to figure out where this is, we're just going to do that to another side. So if we find 2 of them, I know that all 3 of them are going to meet at a point, so I can really just use 2 of them. So let's look at DF. So the length of DF is 7 units because it's flat, so I can just count it. Half of 7 is 3.5. So I go over 3.5. There's my midpoint. So to find that median line, I connect my midpoint to the opposite vertex. This midpoint is on DF, so the opposite vertex is E. Okay, and so where these 2 points cross, that's where my centroid is going to be. So the centroid here is at -1, 2. And let's name this point C. So I'm also going to let's name this one A. All right, so to verify the 2/3 rule, I want to use one median. So one of these median lines. So if I'm using the line AF, so to verify the 2/3 rule, FC should be 2/3 of FA. It should be 2/3 of the way from the vertex to the midpoint, or to the centroid, as it is from the vertex to the other side of the triangle. So to find these, I need to use distance formula to find the distance between F and C. The coordinate of F is 2, 0. And the coordinate of C is -1, 2. So I'm going to find these lengths, or distances, between 2 and -1, that is 3 units. Between 0 and 2, that is 2 units. So if I add these together, 9 plus 4 is 13. This is the square root of 13. The square root of 13 is approximately, I'm going to round it to the nearest tenth. And that is 3.6. Okay, so this one was FC. So I've got 3.6. And the next thing I'm going to find is FA. So to find FA, I use those coordinates. F is 2, 0. A is -2.5, 3. So then I find my distances. So the distance between 2, 0, and negative 2, 5 is going to be the distance between 2 and negative 2.5. So altogether, that's going to be 4.5. And then this is a distance of 3. So I got 4.5 squared plus 3 squared. So 4.5 squared, that's 20.25, plus 9 is 29.25. So the square root of 29.25, that is approximately 5.4. So let's think about this being 5.4. If I do 2/3 times 5.4, I get 3.6. So that checks out. That verifies my 2/3 rule. So we have to use our estimates there because figuring out the relationship between those square roots is a little bit tougher. So now let's look at our example 2. So this is how to find it graphically. Let's look at how to find things algebraically with these examples. So it says find x if LR is x plus 9 and LX, the entire thing, is 2x plus 9. So LX is the entire median and LR is from the centroid to the vertex. So the centroid to the vertex, LR, should be 2/3 of LX. So if I plug in these things that I know, 2/3 of 2x plus 9 should equal x plus 9. So now we're going to multiply this in. So 2/3 times 2 is going to give me 4/3. 2/3 times 9 is going to give me 6. So then to solve it, I'm going to subtract x from both sides. So 4/3 minus 3/3 to make 1. 4/3 minus 3/3 is 1/3. Okay, so then I subtract 6. 1/3 x equals 3. Now to get rid of this 1/3, the opposite reciprocal, not the opposite reciprocal, sorry, the multiplicative inverse of 1/3 is 3. So I multiplied it by 3 to cancel it out. And we get that x equals 9. So that's the number that would make that 2/3 rule work. So if we look on the back, there were some more examples. So let's just look at these first ones, 1 through 5. And we're going to label each one, and then we'll see if we need to go any further. So for this one, GF is 15. Find KG. So since this is from the centroid G down to F, the midpoint of that segment, that's 15. And remember we said that the top part is supposed to be twice as long as the bottom part. So this is going to be 2 times 15, or 30. So the measure of kg is 30. All of these are separate questions, so I'm just going to take my 15 away so I can relabel it. So for this one, JG is 13. Find JE. So JE is the entire median. So I know that 13 is 2/3 of the entire median. I can also say that I know that this is twice as long as GE. So from there I can find that GE is 6.5. So if I know that GE is 6.5 and JG is 13, to find JE, I just add those together and I get 19.5. All right, so for our next question, this one asks, JL equals 22. So the whole thing right here is 22. Find FL. So if this is a side of the triangle, I know that the median goes through the midpoint, so F is the midpoint. That means that this is going to be half of the entire side, 22. So FL is 11. All right, so let's look at our next one. If KE is 20, find KL. So KE is 20, find KL. So that's from the vertex to the midpoint. That's half of it, so this side's also going to be 20. Therefore, the whole thing is 40. So that one's going to be 40. And if DL equals 24, DL, the entire thing, is 24. And we got two things that we need to find. We need to find LG and DG. So remember that this splits it up into thirds. So this is 2/3 and that's 1/3. So that means that I need to do 24 divided by 3. And 24 divided by 3 is 8. So 1/3 of it is going to be 8. And then this one's twice as long, so this one's going to be 16. So DG is 8, LG is 16. All right, and then let's look at one of these down here where we're going to find the centroid. So remember, the first thing is to find the midpoints. So 1, 2, 3, 4, 5, 6, half of that is 3. So there's a vertex. A midpoint connected to the opposite vertex. Same thing on another side. So this one, I see that it goes up 6 units. The midpoint's going to be at 3. Draw that straight line from the midpoint to the vertex. Let's do the third one just to make sure we did it correctly. This one also goes up 6 units on this side. Or it goes out 3 units. So we can use either one of those to find the midpoint here. And whenever I draw this, the centroid should be the spot where all 3 lines cross. So right there, that's my centroid. I'm just going to label it. So my centroid is at -3,